Hello, in this video I'll be showing you, uh, this video will be about linear interpolation. So, yeah, anyway. So say we have 2 points. One here, and one here. Let's say there's some value assigned to each point, like maybe some number. This point has a number of, say, -8, and this one is like +7. And then let's say we want to find the value, like what would the value of a point be somewhere in between these 2 points, based on these values and the position of the point that's in between them. In this particular case, we would use linear interpolation. So I'm actually going to delete these because we don't need these anymore. What we're going to do is we're going to do function. And we're going to do a times 1 minus t plus b times t. Sometimes this is a, and then sometimes these are like x and then y, but for this video, I'm just going to do a, b, and t. And then I'm going to create another variable called points. Set this to 16. And then we're going to do another one, p1 and p2, and this is just going to be equal to negative 3 and positive 5. And then what we're going to do is we're going to do local height is equal to lerp. And we're actually not going to set this to 0. We're going to set this to p2 and p1. Then we're going to do instance.newPart. If I run this, it should look like this. So actually, I need to create a new part. Do 0, 0, 0, then where is it? Right there. And then go back, delete it, run it. So this is what it looks like. So linear interpolation. So when I originally showed the two really small points, where I said that each point had some number assigned to it. In this case, we have 2 points, p1 and p2. The point is just stored as the number associated with that point. The actual location of it really isn't. We don't care too much about it. So we have p1, it's -3, and then we have p2, which is 5. And so what we're doing is this is going to be positioned at what? 5. This is not very accurate. Oh, the reason why it's not working is because I multiplied this by 5. So if I actually get rid of this here, you can see it looks different. So the position here is at -2.5. It's close enough to 3. But see, the index here starts at 0. So it doesn't start at 0. I'm sorry. It starts at 1. That's why it does not start here at -3. And this is at 5. So then we can multiply the height by some number, say 10, and then it'll be really high there. So that's simple linear interpolation. What if we want to add multiple points to our linear interpolation? Well, this isn't really going to work anymore. So we're going to have to do something else. We're going to have to write table, and then we're going to have to add whatever points we want. So 5, 3, 10, 8, 7. So that's what we have here. Then what we can do is we can do, so this stands for multi-point lerp. I don't know what the lerp means. What we can do here is if points, what we can do is we can do a is equal to math.floor points, and then we have to add one, so +1. The reason we have to add 1 is because indexes start at 1, not 0, so this has to be 1. If not, then we'll actually write, here we actually have to do points, and then we have to put this in here. I don't know why I put points in there. So if A or B does not exist, we will not perform the calculation, because if they do not exist, then if either of them don't exist, then it will be nil. And if we try to do any type of arithmetic on a nil value, um it will become like it'll have an error. So we do not want to do that. So now what we will do is we will return lerp, but instead of just a regular lerp, we'll have to, well, you know what, we will just do A and B, but instead of T, we'll have to do T%1. And then we can copy the same thing here, except we can't have P1 and P2. And points is going to be a little bit different. So points is going to be hashtag points, which just means the length of the amount of how many points we have. So 1, 2, 3, 4, 5. Or I can like maybe make this, I don't know, 7. So what this is doing, points in between, is, so we have what, 1, 2, 3, 4, 5 points. There's going to be 7 points in between these 5 points. That's the whole point of it. No pun intended. Points in between 1 points, point, pound. And the height can no longer be this. It has to be MP lerp. And then the points just going to be points, and then x divided by points in between. And then, let's see, does this work? No, it does not, because height is nil. Okay, so this is what happens. I actually did not expect it to look like that. We're gonna go up here, and then we're actually not going to set this 10. We're going to set this just a regular height. And so now you can see we have a multi-point linear interpolation. So now I would like to show you something that we call an easing function. So here in Desmos, I have a graph of this really smooth line. I can change how smooth it is. So right now it is linear, it is a straight line. If I do this, it looks a little bit smoother. So if we go back here and I run this, you can see that this looks very pointy. It's very sharp. So what I can do is I can emphasize the sharpness of it. You can see it looks really sharp. So we can do a few things. Number one, we can set this to something big like 32. So it generates that many parts. It still looks very sharp and pointy. So what do? We need to make something called an easing function. An easing function. So we need to take this and put this like right here, and then write. So here, I would have to copy this whole equation here, put it into this, what do you call this, function. Now, one really easy easing function, if you just want something super simple, you don't want to have to copy all this complex math down, is you could return negative 2x cubed um, plus 3x squared. And I can actually show you. It looks like this. Very interesting. And I can probably, no, I don't know. Anyway, use something like this. If you just want something simple, you don't want to have to copy all of this. But when you do this, you won't be able to put g. You just have an x. But for the purposes of this video, we're going to do this really complicated one. The reason I will do the complicated one is because you can modify the like this the how you can like change the shape of it a little bit instead of this, which is you can't really change the shape of it, but it already like exists. So in here, you will want to write this here. Also, fun fact, when you do an exponent where it is a number between 0 and 1, it's the same as getting like the nth root of that number. So an example of this would be if I did like sqrt. 2 is also the same as writing 2 to the power of 1 over 2. Or I could write, say, 1 over 4. Or no, let's just do like 1 over x. Okay. Then I can write, oh, no. 1 over x. Nth root x 2. It's the same equation. Anyway, that's just something I thought was interesting. So 1 minus c up here, we're going to have to then write plus negative x plus 1. So now we wrote that. What we can do now is write c is equal to math.max. This calculates whether this, if, well, you can actually read this with what this does here. Math.max, if this value is larger than 0, it will return this value. If 0 is larger than this value, it will return 0. It basically prevents any number from getting less than 0. And then d, you have to write d up here. G times x minus g divided by 2. And that should be everything. Let's try it. So instead of writing t%1, we'll write easing t%1. And then the g value, we can just set this to 1. Run it. And you can see it looks much smoother now. It does not look like a line, but I can make it not smooth, set it to 0, And now it looks linear again. And I could also set it to like 5, and then it'll look kind of cool. It has like looks like a square, like a pulse or square wave, but with rounded corners. Kind of interesting looking. Um, anyway, let's see. This is really cool, but what if we want to like bilinear or trilinear interpolation? So I can do like 1 dimension. 2 dimensions. So that's a multi-line comment. So uh, bilinear interpolation looks very complicated, but it's actually simple. Let me show you. Let me make this kind of far away, like 10. So let's say I have these 4 points, and I would like to calculate what the value is at this point that's at this position relative to this square. Or this, I mean, you can kind of look at it like a square. So it looks very difficult, but it's actually very easy. What we can do is we can linearly interpolate between this point and that point, or just interpolate, it doesn't have to be linear, between this point and that point. So this is the interpolation point. And also do it with these two. So these two and this two. So now we have these 2 points. So all we have to do now is just do a linear interpolation between these 2 points, and then we can get to that point. So script. Let's see. So here we'll just write something like this. Then we can do is copy the lerp function. So this is a lerp function here, and the easing function here. What was I gonna do? Oh, right. So then we can write and then the last one, we'll return it. It'll be lerp. Lerp1, lerp2, y. And for consistency's sake, we can do so A, B, C, D, E, and F. So we can say E and F. So now I just got these letters. Set this to like 32. Also set this to 32. This is useful if you have a slow computer so the loop doesn't crash the script. Why? And we can divide this by the y size, x size. So if I run it, it should look like this. Now it can't really tell what's going on. So what we can do, let's move these here. Run it, and you can see it looks different. However, it still looks very linear. And I can keep messing around with it. How do we make it less linear? So we can still implement the same type of easing function, and you can still use the same one I showed you earlier, but we're not going to. So in lerp, we can either replace it here or replace it here. I think what I will do is do x equals. And these two numbers have to be the same. And if you apply it to this to one, you have to apply it to the other. So if we run it, you can see it looks a bit smoother. Same with this. Can't really tell because the random number is not going very well. I can do 30, 30, 30, 30, 30, 30, 30, 30. Okay, so now you get a bit more variation. Or not variation, it's easier to see what's happening. Now you can also see you have these gaps. So in this case, what you can do is set, well, actually, it's going to be a little bit complicated because this is positive and negative, and you can't change the size to negative. I guess what you could do is height plus 30 divided by 30. And then times, actually plus 30 divided by 60 times 30. And then now you have to also set this to height divided by 2. Oops. Okay, so you can see it, there's no gaps anymore. But I did not do something right. Because I need to use this divided by 2. There we go, okay. So I can keep running this and it'll generate this random looking, it looks like a Minecraft chunk. Although Minecraft doesn't really work like this. So that's how bilinear interpolation works. But now you may be wondering, how do you do trilinear interpolation? So trilinear, you may not even know what trilinear interpolation is. So I will show you. This. So you have this cube. Okay. It's like bilinear interpolation. You can see these 4 points, but they're stacked on top of each other to make a cube. So now I can grab this, put this cube somewhere inside this, well, this point and somewhere inside of this cube. So how do you do trilinear interpolation? Well, that's very simple. You first do a bilinear interpolation on this part, or really it doesn't matter just as long as it's on the correct parts, but I'll do it on this part. On this top part, then I do bilinear on the bottom part. So it looks like this, but this is not done yet. So you do a linear or just a another interpolation from here to there. And that's how you do trilinear interpolation. But let's actually show you in a script. So we can copy the easing lerp and Bilirp functions. So what I can do now is do A, B, C, D, E, F, G, H, X, Y, Z. And then we do HI is equal to Bilirp. A, B, C, D, X, Z. J is equal to A, B, C, D. So this is E, F, G, H, X, Y, or no, Z. The return blurb I, J, Z, no, Y. And then do for x equals, and I can actually copy the, what do you call this, a bilinear one, and then do, so we don't have z size, but we can make it. So that's z size, and I just have to move this here, tab, and then make this go down. So this is not going to work. We have to do .1 C frame x, y, and z. And this is not height, this is density. I lerp all this stuff here. We also need our points, so actually I want to try something real quick. Points equals table dot create how many 8 value math dot random negative 10 10. And I'm not going to run this here. I'm going to print points. Is it the same? Yeah, it's the same. So that's not really going to work. So I could just write like a table with a really long line like math.random and then like negative 10, positive 10, and then just keep writing this over and over and over again. But that's gonna make a one really long line. What might be easier is just do for I equals 1, 8. Make sure it's 8 here. It has to be 8. It cannot be more, it cannot be less. Well, it can be more, nothing bad will happen, but it cannot be less. But you have no reason to do more, so because if you do more, it just nothing, it won't do anything. There we go. And then here, try lerp points 1, 2, 3, 4, 1, 2, 3, 4. X will be x divided by x size, y divided by y size, z divided by z size. And then down here, I will write if density is more than or equal to 0, then create a part. So if I run this, I accidentally right-clicked, but nothing happened. Okay, that's good. We can see it looks kind of weird. It looks like this. because that is what like trilinear interpolation does. It basically it generates a point here, here. It's this point here is invisible, but here, here, it basically creates a cube. So it creates 8 points for each corner. So point there, point there, point there, and point there. And each point has a value, random value. So the value here is less than 0. Value here is basically everywhere where there's no blocks is less than 0. Everywhere there is blocks, it is more than or equal to 0. Run. Let's see what happens. So it looks like this. Looks kind of like a Minecraft chunk. It looks even more like Minecraft than the other one. Anyway, that is how you do interpolation in Roblox. It's a rather extensive tutorial on interpolation because it's not just one dimension or 2 dimensions. You can have it in 3 dimensions. So here's how you can properly add the easing to triloop. So if I run this, it looks like this. Normally, if I keep running it, we can get something different. But yeah, it looks kind of linear. We can do so we can write this. But instead of x 3 times, you write x, y, z, y, z. Run it. And so it'll look like this. Uh, what? That's an interesting coincidence. See, it looks like this.